மாணவர்களின் சிந்தனைகளை வடிவமைக்க எஸ்என்எஸ் இன்ஸ்டிடியூஷன்ஸ், மாணவர்களின் தனித்திறமைகளை மேம்படுத்த எஸ்என்எஸ் இன்ஸ்டிடியூஷன்ஸ், மாணவர்களின் சாதனைகளை போற்றும் எஸ்என்எஸ் இன்ஸ்டிடியூஷன்ஸ் கோவை.
Hi everyone, this is me Vijay Kumar, Assistant Professor Department of EEE, that means Electrical and Electronics Engineering, SNS College of Technology. So in this video lecture series we are discussing about electrical machines in robotic automation subject at the topic of motors and drives. So the unit of motors and drives we are discussing today topic will be operation of linear motors. So that linear motor is somewhat different compared to the another existing motors, that will be a PMDC motors or a stepper motors or a servo motors, right? So that will be a linear one. So today class we will discuss about introduction, block diagram, characteristics, types, advantages, disadvantages and applications. The linear motor operates with an AC power supply and servo controller, which are often the same as those used for a rotary servo motors. The linear motor primary part is connected to the power supply to produce a magnetic field, and by changing the current phase in the coils, the polarity of each coil is changed. The attractive and repelling forces between the coils in the primary part and the magnets in the secondary part causes the primary to move and generate a linear force. The rate of change of the current controls the velocity of the movement, and the amperage of the current determine the force generated. So that will be a linear motor. Just imagine that the motor, why the motor is always in a rotational shape or a rotary shape. So we are splitting the motor, we are opening the motor, so like I say we are cutting and then roll out, right? So that will be some kind of linear motor applications we are imagining. So we have a primary. So primary, for example, top of the portion will be primary and then bottom of the portion will be primary. This is a one type. Otherwise the primary will be a bottom side and then secondary will be a top of the side. So just imagine when we are supplying the primary or a stationary portions or a stator, the rotor is automatically starts to rotate. Now the stator will be a linear one because already we are cut and then rolled out. So during that condition, when we are giving the supply, the rotor will be moved from one direction to the particular direction. The characteristics will be speed and then pole pitch meter. So this will be directly proportional, and also the effect of supply variations will be the indirectly proportional. And also we have a different kind of linear motors. Electrostatic linear motor, electromagnetic linear motor, piezoelectric linear motor, magnetostatic linear motors, and then electromagnetic will be induction, synchronous and brushless DC motor. Again the synchronous will be transverse flex, homopolar, classic with PM, and then reluctant. The classic with P permanent magnet will be toothless and with tooth. Toothless again surface mounted inside, and with the teeth will be surface mounted and then it's set. So this kind of motor is very very important, and then it have a power factor and high efficiency and extra vibrations with distortions and end effect, large air gap, the high in cost and heating issues. So it will be some kind of disadvantages of linear motors. And also the linear motor, we don't want any kind of power angle changes. For example, when we are changing the rotational movement into linear movement, so we need some kind of Victor gear or a bevel gear, so that kind of concepts. But in a linear motor we don't want any kind of external gearing mechanism. So when we are using the gearing mechanism, it will be give some kind of losses, the mechanical losses, friction losses, vintage losses. But here the linear motor don't have that kind of mechanical or a friction losses. And also the applications, the linear induction motor can be used for a trolley cars, for a internal transports in workshops. And also the linear induction motor can be used as a booster accelerator for a moving heavy trains for a rest or up the inclines. And also the linear induction motors are used as a propulsion unit in marshalling yards in place of shunting locomotives. And linear induction motor has a superiority over conventional rotary motors for a speeds above 200 km per hour. The linear induction motor is also used in magnetically suspended trains where conventional motor cannot be used. So that kind of things in a real-time applications. And so this is the linear motor. So we have a different kind of motors, and also without any kind of gearing arrangements and then gear wheel mechanism. mechanisms. So for example, just we considering a bullet train. So in this train, so normally the train will runs up to 90 kilometer to 120 kilometers. So when the train is moving 120 kilometer, it will have some kind of huge amount of friction as well as huge amount of pressure on the rail systems. The rail system will be a very heat, and then it should be produce very amount of things. But at the same time, just imagine that the rotor will be, that means the train will be elevated from the train mechanism. Now the train mechanism will be elevated and then floating in the air. So the gap between train wheels and rail track, it will be considered as the air gap. Now when powering of the rails or powering of the trains, it will be give the huge amount of speed that will be at 200 kilometer per hour and then above. So I hope you understood the basic concepts of linear motor, and then applications we will see the next topic in another class. Thank you.